Hi guys, we will continue on the Unit 4 of Form 3 Chemistry. And last time we talked about the use of different metals and different ways of extracting metal and how the metal reactivity is related to the method we use to extract them. Now, today we will only focus on this page. Now, this page, I can tell you, very important, very important because this page consists of a lot of chemical reactions and usually in the exam you will expect to see at least one full question concerning about just this page, okay? And having said that, it must be quite challenging, so get yourself prepared. Now, you see we have a huge space here and I put down calcium cycle. Now, this page is related to a lot of different calcium compounds and how they can react to change from one to another. Okay, so that's why at the end we are going to draw a cycle summarizing all the reactions, all the necessary conditions and terms, something like that. But before we start to work on this one, let's have a look at down here. Okay, you see there are so many different reactions, names, etc. Okay. By the way, this part, why are we so concerned about calcium compound? Is because this topic is rocks and minerals, right? And rocks, besides those ores that we talked about last lesson, actually there are many other rocks that could be also useful. And one of those are the rocks that consist of calcium compound. Okay, so that's why here we are going to study the chemistry of calcium compound. Now let's start with something called calcium carbonate. Okay, calcium carbonate. So calcium carbonate. Now, if you are interested, but this is not necessary in Form 3 chemistry, calcium carbonate is CaCO3. This is the chemical formula. Okay, calcium carbonate. All right. So calcium carbonate is a white solid and it is insoluble in water. Insoluble in water. Okay. So this guy is insoluble in water. Okay. Later on, you will know there is an experiment that can prove that calcium carbonate is insoluble in water. So now, the first reaction is that when we heat the calcium carbonate using Bunsen flame, then it will decompose into calcium oxide and carbon dioxide. So this reaction is what we call thermal decomposition. Thermal decomposition. Now, decomposition basically means it splits into smaller compounds. Okay, so decomposition basically in Chinese, okay, we split into smaller compound. And thermal basically means heat. So this decomposition occurs only when we are at a high temperature. So that's why this reaction, you can tell, it requires strong heating. All right. So calcium carbonate is decomposed into calcium oxide and carbon dioxide. Now again, if you are interested, calcium oxide, the chemical formula is CaO. Okay, just put it here, CaO. All right, and carbon dioxide is obviously CO2. Okay, so actually you can tell the calcium carbonate decomposed such that one carbon and two of its own oxygen atoms will become carbon dioxide and the rest will be calcium oxide. Okay, so like this is the first reaction. Now you see here, because calcium carbonate is a solid, calcium oxide is also solid, but carbon dioxide is a gas. So let's just say we have 1 gram of calcium carbonate at the beginning. After we heat it, it will decompose into these two products and the carbon dioxide gas will escape from the mixture. So at the end of the day, after you heat it, the total mass of the solid will actually decreases. Okay, so here, after heating, the mass of the remaining solid decreases. Okay, as carbon dioxide produced has escaped it. Okay, So this is the first reaction, and you see calcium carbonate is converted into calcium oxide. Okay, so down here, the second reaction is to add water to calcium oxide. Now, first of all, calcium oxide is actually a white solid. So these two are both white solid. Actually, later on, we talk about another one which is called calcium hydroxide. It is also white solid. So we have a bunch of white solid. That's why we need to know the reactions in order to distinguish between one another. Otherwise, they are all white solid. You have no idea which one is which. Okay? Now, addition of water to calcium oxide. So this is the reaction. Not very difficult. Again, I try to give you the chemical formula so that you get a better understanding. So calcium oxide, like I said, CaO. Okay. Water, you know, it is H2O. Okay. Now calcium hydroxide. Now oxide means oxygen, hydro means hydrogen. So calcium hydroxide, you can tell, it is consisting of calcium, hydrogen, and also oxygen, so 3 elements. And the formula is a little bit complicated. It is like this. So CaOH2. Now, this one means that it consists of 1 calcium atom, 2 oxygen atoms, and 2 hydrogen atoms. Okay? And that makes a lot of sense once you look into their chemical formula, because just add them together, right? Then you have this one. All right? So that's the idea. Now, this reaction produces calcium hydroxide, another calcium compound. So altogether 1, 2, 3. Now you know how to convert this one to this one and then this one to this one. Okay? Now, calcium hydroxide, this solid, is slightly soluble in water. Slightly soluble. It can dissolve a little bit in water. Okay? And actually, lime water, did you remember lime water? We learned it in Form 2. Lime water is a solution which is used to test for the presence of carbon dioxide. Okay? But we don't know exactly what is lime water in Form 2 until now. Now you know that actually lime water is a saturated solution. Okay, right. So that's the idea. Now later I will fit in those common names for these compounds, so don't worry. Now, the third reaction. So right now, when you add water inside, we have calcium hydroxide, and then make use of this calcium hydroxide, we can prepare lime water. Now here, the third reaction is we try to introduce carbon dioxide into calcium hydroxide solution, which is basically the lime water. Now the reaction is more complicated because this time we have 2 reactants forming 2 products. Now let me break it down for you. So first of all, calcium hydroxide reacts carbon dioxide to produce calcium carbonate. Calcium carbonate. So you can think of the calcium compound has changed from hydroxide to carbonate. All right, and because you know carbonate consists of carbon and oxygen, so actually this entire carbon dioxide has incorporated into the calcium carbonate. So it's like this plus this equal to this. But you realize one thing is that here hydroxide means it has hydrogen. But from calcium carbonate you can't find any hydrogen, right? So it has to be another product that carries the hydrogen. Instead of forming hydrogen, actually it forms water as the other product. So this is sometimes how I think of, how I memorize the equation, or try to verify the equation, is that I try to consider where the atoms from the reactant ends up in the product. So this allows me to predict or verify my answers. Oh, again, let me fit you with those chemical formulas. Calcium hydroxide is like this one, right? And then carbon dioxide is this one, right? Calcium carbonate is this one, we did it, and this is water. So now you can consider, like I said, like these two combines to form calcium carbonate. So you see, calcium is there, carbon dioxide is there, if I use different colors to show you. So calcium, the CO2, they are all here, right? But of course, here it misses out an oxygen atom. So perhaps this oxygen can also be contributed to form the calcium carbonate. So here, OH bracket 2, now with one oxygen used to form calcium carbonate, we have one oxygen left and two hydrogen left, so we may as well form the water. Okay, so sometimes we can understand the reaction in this way. That allows us to memorize the equation better. Okay. All right. Now, going back to this reaction. Now, do you remember? Just now I said that calcium hydroxide solution is basically lime water, right? And now we are adding carbon dioxide into the lime water. What do we expect to see? Carbon dioxide, lime water. It rings a bell. It should form a milky solution, right? The solution turns milky. Okay. Now here, this is the reason why it turns milky. Actually, it turns milky because it forms calcium carbonate. It forms calcium carbonate, and calcium carbonate is actually insoluble in water. Insoluble in water. Okay. If you remember here, I did talk about that at the beginning. Calcium carbonate is insoluble in water. So, if this is insoluble in water and they form, when we mix, it forms inside a solution, right? You have something insoluble form in a solution. So, this insoluble calcium carbonate will exist as a white precipitate. So, this guy over here will exist as white precipitate, which turning the solution milky. You get it? You get it? Because we form insoluble calcium carbonate, so it exists as white precipitate, and this white precipitate is the reason why the solution turns milky. So the milkiness of the solution is due to the formation of insoluble calcium carbonate. So now you know what is the white thing when you bubble carbon dioxide into lime water. The white thing is calcium carbonate. Okay? So that's the idea. Now, but the story doesn't end here. We still got more of a special episode as a sidetrack. So in fact, once we have the calcium carbonate form, if we are able to provide excess, that means too much or a lot carbon dioxide into it, then the calcium carbonate actually can undergo further reaction to form calcium hydrogen carbonate. Very complicated, right? Calcium hydrogen carbonate. And this guy is actually soluble in water. It's actually soluble in water. All right. So calcium carbonate does not dissolve in water, but calcium hydrogen carbonate is soluble in water. So the white precipitate actually dissolves. Okay, dissolves. Okay, when we add excess carbon dioxide. If we add excess carbon dioxide. Okay, so this is the word equation, which is very complicated, I understand, especially when I chip in those chemical formulas. Here, calcium carbonate, like I said, carbon dioxide over here, water H2O, and calcium hydrogen carbonate, very complicated, Ca, open bracket, this one, okay? Calcium hydrogen carbonate, all right? So you may try to see if those atoms are balanced. You can count every single atom, and it turns out that the left-hand side and the right-hand side are actually the same. Okay, so this is the idea, and this guy is soluble in water. So these are all the reactions. These are all the reactions. Okay, is it so frustrated? Is it too overwhelming? Now that's why I reserve this place. Now we are going to, again, go through all this reaction, but we try to make it simple. We try to create a cycle that entails all those conversion between calcium compounds, between all the calcium compounds. So let's get started, shall we? Now let's start with our calcium carbonate. Okay, calcium carbonate here. Okay, calcium carbonate. Now here I will also introduce the common name. Now calcium carbonate, CaCO3, has a lot of common names. Or in other words, a lot of the substance will have calcium carbonate being the major component. So here often you will hear three names concerning the same thing, which are the chalk, limestone, and marble. Okay, so all these three substances, they are mainly made of calcium carbonate. Okay, so when you see these three terms, you can relate them, you can consider them as calcium carbonate. Okay, now the first reaction is when it is converted into calcium oxide. Okay, calcium oxide. And this reaction, you remember, it requires strong heating. Okay, and this reaction, if you remember, also release carbon dioxide. Okay, basically one split into two. But the cycle, I want to focus on the calcium compound, so that's why only the calcium compound, I will use the red ball pen to show it. Okay. Now calcium oxide has a common name, just like calcium carbonate. Calcium oxide is called quicklime. Okay. So when you see quicklime, you should know that it is calcium oxide. Okay. Now you may ask, why do we have to know this common names? It's because actually, when you go to like the hardware stores, or you go to some kind of like people who sell flowers or sell any agricultural goods, right? They sometimes have to use these chemicals, but they understand this chemical in their common names, not their chemical names. So, for example, if you look for calcium oxide and you walk into a hardware store and you ask for calcium oxide, like the shop owner doesn't have a clue what are you talking about. But if you simply say, hey, I want some quicklime, then he will understand. So as a chemistry student, it would be best if you know some of the common names of chemicals, so that at least you know what it is when you hear that name, all right? Okay, now so for calcium oxide, the next reaction, if you remember, is the addition of water. But here, we need to specify a little bit. So I want to start by adding, a few drops of water. Okay, add a few drops of water. And when we add a few drops of water, if you and this reaction will actually produce calcium hydroxide. Now, don't worry, later on I will show you an experiment and you will know why I have to add a few drops of water. Then, like here, calcium oxide reacts with water, right, to form calcium hydroxide. Okay, now calcium hydroxide has another name. We call it slaked lime. Okay, slaked lime. Okay, in Chinese it's quite interesting. This one is called this one. This one is called this one. Okay, so it's like raw and cooked. Okay, so calcium hydroxide. Okay, we also call it slaked lime. Okay. Now, calcium hydroxide, we can actually add more water. Now here we add a few drops of water, but now I want to add more water. So adding, excess amount of water. We'll try to add more water inside. So when we add more water inside, the calcium hydroxide will actually dissolve in the water to form a solution. Like I said, calcium hydroxide down here is only slightly soluble in water. So if you add a few drops, you will actually get a solid. you will actually get a solid of slaked lime. Only when you add excess amount of water, then the slaked lime is able to dissolve in water, forming the lime water. So in this step, because it's simply dissolving in water, it is still calcium hydroxide. It is still calcium hydroxide. So it is not a chemical change. This is actually a physical change. But because this time it is a calcium hydroxide solution, okay? It is a calcium hydroxide solution because we add a lot of water. So this guy is called lime water. So lime water is actually the common name for calcium hydroxide solution, okay? All right. And lastly, actually not really lastly, but the second last step is that when we bubble carbon dioxide into calcium hydroxide, like here, if we add, okay, adding, okay, small amount, for some reason I put down small amount of CO2, okay, adding small amount of CO2. So this is basically the lime water test, right? If you add small amount of CO2, then the calcium hydroxide reacts with carbon dioxide to form calcium carbonate and water. That the formation of insoluble calcium carbonate will result in the white precipitate. That's why it turns the solution milky. Okay, so this one is referring to this one. Okay, addition of carbon dioxide to calcium hydroxide. This is the reaction. This is to convert calcium hydroxide into calcium carbonate. Okay, all right. Now you see, I add small amount. What if I add more? What if I add more? Okay, so if you add more, if you add a lot of calcium carbonate, then you will expect to see something like this. Okay, if you add a lot, adding excess CO2, then well, it would first becomes the calcium carbonate. But as you add more, okay, so like I said, it's a more of a side story, then it will become what? Calcium hydrogen carbonate. Okay, it will become calcium hydrogen carbonate. Okay? And you realize that this one is insoluble, but this one is soluble in water. Okay? All right, but this one is the side track, so it's like out of the cycle, and we will mostly focus on the cycle, how we can convert calcium carbonate, how can we convert between calcium carbonate, calcium oxide, and calcium hydroxide. Okay, so that's the idea. Okay, so that would be the whole cycle. If you wish, you can add the chemical formula into the cycle. Okay, so that would be all the reaction. But just one more thing I need to highlight to you, which is actually the second one. Let's see. It's already very messy here, so probably I will here. Let me draw a smiley faces here. Okay, and that means you have to look at here, this corner. So there are some remarks I would like to add regarding the reaction between calcium oxide and water. So we say that the reaction between, okay, quicklime, which is the calcium oxide, and water is highly exothermic. Okay? Now, what do you mean by exothermic? That means release a lot of heat. Okay? So this particular reaction, you need to pay extra attention and cautious to it, because when you perform this experiment, the reaction is highly exothermic, so it releases a lot of heat. So when you actually add the water into the quicklime, you will hear some hissing sound, and you will also see a lot of steam coming out. Because the reaction generates so many heat, it is able to boil and vaporize part of the water that you have actually added into it. Okay, so this one you need to pay attention to. And because of this heat generating property, actually this reaction actually used to generate heat in some kind of warm pack, heat pack, or even have you heard about 懶人火鍋? 懶人火鍋. Actually, 懶人火鍋, the heating material, where you pour the water inside and then it will start to get hotter and hotter, right? That heating material actually consists of quicklime. So when you pour in water to the quicklime, it starts to react and generate a lot of heat. So this is something that you may need to consider. Okay, so you may think about like the like this is the application of quicklime. Of course, it has other applications, but this is actually one of them. Okay. So and also you have to pay attention is that calcium oxide is quite corrosive. It's quite corrosive. So you never touch it with your bare hands. Okay. So now that's it for the calcium cycle. Now the lesson doesn't stop here. Actually, we are going to look at a series of demonstration of the experiment concerning about all these reactions. So I'm going to demonstrate to you a series of experiments where you can find it from our lab workbook. Experiment 4.1 here. Okay, and according to the menu, there are 3 parts, part A, B, C. So I will do it basically one by one, and while I'm doing this, I'm also going to highlight some key concepts and some of the things you have to pay attention to. Okay, so let's get started. First of all, safety goggles on, and the first thing we're going to do is we are trying to study the action of heat on calcium carbonate. Okay, this is calcium carbonate. All right, so first of all, we are going to have 3 spatula measure of calcium carbonate. So doesn't really have to be very accurate. Just 1, 2, and 3. All right, that should do it. Maybe a little bit more. Okay. And then we need to we need to light up a Bunsen burner. Turn it into a blue flame. And what we're going to do next is to heat it. Okay, heat it under the Bunsen flame. Now, according to the menu, we have to heat it for 15 minutes. So, yeah, let's just heat it for 15 minutes. And pay attention that I am doing this swirling motion because that will make it heat more evenly, and that will prevent the cracking of the boiling tube. And I also make it tilted. Actually, this is not very necessary. We usually tilt the test tube while heating a solution, because if the solution gets boiled, it will shoot out, and if I tilt it, then at least the solution will not splash towards me or go up and then go down and then hit my hand, right? But here actually it's not necessary, but this is the usual drill. Alright, let's just be patient and heat it for 15 minutes. And you know what we are trying to do here is to do a thermal decomposition of calcium carbonate, and you will expect to have calcium oxide, also known as the quicklime, also carbon dioxide. Okay, these two you will expect to be the product. But you know, calcium oxide or the quicklime is a white solid. The calcium carbonate is also a white solid, so you don't really see any color change on the solid. And carbon dioxide, of course, is a colorless gas, so you won't expect to see any observable change. Now, some student, when you see carbon dioxide or any gas that is produced, and you may think, oh, there should be colorless bubble, and especially during the exam, okay, you see gas is produced and you put down colorless bubbles given off in the experiment. But pay attention, right? When we talk about gas bubbles, we are talking about gas formed underwater, okay? But you see there are no water here, so how could you see gas bubble, right? So be more authentic when it comes to observation, okay? Don't just memorize, okay? And yes, by the way, this experiment is supposed to be a group task. So, and I also mentioned that there are altogether 3 parts. So, in reality, if you are doing this within your group, so while one of you are doing this boring stuff, the other group mates should be doing part B and part C. So, treasure your time in real laboratory exercise. Okay. Okay, so 10 minutes has passed. Still got 5 minutes to go, but I think that should be more or less the same. Okay, and plus we are not going to convert all the calcium carbonate into calcium oxide, so it should be fine with just 10 minutes. We don't have to really heat it for 15 minutes. So now I should stop the heating. All right, and the next step is we are going to add water into this calcium oxide. All right, but of course we will wait until it cools down. Otherwise, it may crack the very hot boiling tube. So let it cool down for a bit. Now you can see after I heat it, it is still a white solid. Still a white solid. Okay. So just let it cool down for a while. Now, I think it has cooled down already. So right now, what we are going to do is we're going to add some water into the calcium oxide and see what we can observe. So first I'm going to add just a few drops. Now, when we add a few drops of water, you should be able to hear some hissing sound and you also see some steam coming out. Now, the reaction between the calcium oxide and water will produce slaked lime, calcium hydroxide. Okay, and this reaction is highly exothermic. That means the reaction releases a lot of heat. So that's why you hear the hissing sound and you also see some steam coming off. Okay, the reaction itself does not produce the steam, but the heat is hot enough, is enough to actually boil some of the water, and that's why you see some steam or water vapor condensed on the boiling tube surface. Okay, so now we are going to add more water inside. So basically we want to dissolve as much calcium hydroxide as possible in order to make lime water. Okay, so we basically add the water. So you see a very milky solution. Now the lime water is supposed to be colorless, but right now here, actually we still got some calcium carbonate remain unreacted, and those calcium carbonate is insoluble in water, so those milkiness, those white precipitate is actually the unreacted calcium carbonate just suspending around the solution. If we allow the solution to stand for a while, you should be able to see a lot of the solid sink at the bottom, but still we got some calcium carbonate suspending in the solution. Actually, if you watch a little bit closer, you already see a lot of white precipitate already decanted at the bottom of the boiling tube. So right now we are going to do a filtration. We are going to do a filtration on this lime water and calcium carbonate mixture. We want to get the colorless lime water out of it. Okay. So we have this filter funnel. Of course, we need to prepare ourselves a filter paper cone. Okay, remember how to fold it. You fold it into half, and then you fold it into a quarter. Then you open one of these pockets. You get yourself a paper cone, just like those you get it from the water dispenser. Okay. Now you put it into the cone, and in order to make the paper cone stick firmly to the inner wall, we must add some water. Okay, that should do it. Now the paper cone stick firmly to the inner wall. So we just pour a small amount of this liquid to the filter paper cone. You can see the filtrate should be colorless, and that one would be the lime water that we are looking for. So right now we are going to do a chemical test to see whether this liquid is indeed lime water. Now, we often use lime water to test for the presence of carbon dioxide, right? And we know that carbon dioxide turns lime water milky. Now, this time we do it another way around. We want to prove whether this one is lime water or not. So we will introduce carbon dioxide into this lime water. So this is the lime water that we have collected. So we want to introduce carbon dioxide into it. And one of the very convenient way to get carbon dioxide is from our exhaled breath. It's from our breath. So what we're going to do is we're going to take a straw. And basically we're going to blow the air, our exhaled breath, into the lime water. So if it turns milky, that means it is really the lime water. Now this one, pay attention you don't suck it, you blow it, and you blow it gently, otherwise it will spill out and it will be all over your face. It would be best if you tilt it to the side, so, and then you gently blow in the breath, okay? Okay, now it should be obvious that the lime water turns milky. So that means this one is really lime water, all right? So that is the idea. Now, again, as a conclusion, what we did at the first place, first of all, we have the calcium carbonate and then we heat it using our Bunsen flame. And during this process, the calcium carbonate decomposes into calcium oxide and carbon dioxide, right? Now, the calcium oxide, once we introduce small amount of water, then the calcium oxide will react with the water to form calcium hydroxide. And this reaction is highly exothermic. That means it releases a lot of heat. So you will hear some hissing sound, and you also see some steam coming off, which condense in the inner wall of the test tube. Okay. Now, when we add excess amount of water into the calcium hydroxide, then the calcium hydroxide dissolves in water to form lime water. Now remember, lime water is a saturated solution of calcium hydroxide. Because calcium hydroxide is not very soluble in water, so that's why just now we add a lot of water inside. The solution is still very milky, not only because we have some calcium carbonate remain unreacted and still there, but also perhaps we have too much calcium hydroxide inside, so they are not able to fully dissolve into the solution. So in order to get rid of that milkiness or get rid of that cloudiness, we perform a filtration, and by doing filtration, we collect a clear filtrate, and that one we suspect that it is lime water. In order to test or verify whether that is really indeed the lime water, we will carry out this very convenient test, blow in our breath, which contains carbon dioxide, and you see now it turns milky, meaning that it is indeed the lime water. Okay, so that one will be part A of the experiment 4.1. Now for part B, it's actually quite easy. What we're going to do is we try to study the action between calcium carbonate and water, basically to see if the calcium carbonate dissolves in water or not. Actually, you already know the answer, but let's just have a look. So we just use a clean test tube. Now, I don't care, I just drop some calcium carbonate inside. Okay, anyway, so I got some calcium carbonate inside, right? And then I'm going to pour in some water and see whether it dissolves or not. So let's introduce some water inside. So it turns into a milky mixture, and it looks like it doesn't dissolve. Let's just add more water inside. Okay, so calcium carbonate is insoluble in water, right? So that would be part B. Okay, so for part C, it's an interesting one. We are going to actually study the action between acid and calcium carbonate. And we are using a two test tube setup, not only to see how the reaction between calcium carbonate and acid is going on, but we also try to test whether the reaction produces a carbon dioxide or not. Okay. Now, first of all, you need to have a test tube, and to that we are going to add lime water. Okay, lime water. So I just pour a healthy amount of it, like that. Okay, and then we will have a delivery tubing. Okay, so the longer end or the end without the stopper, we will insert it into the lime water, just like that. Okay, so remember this is lime water. Now, on the other hand, on another clean test tube, we will be adding some hydrochloric acid. Okay? Again, pour a healthy amount of it. Okay, that should be enough. Now, here is the more technical part. What we're going to do next is we want to add some calcium carbonate to the test tube, but we don't want it to mix with the acid. So how do you do that? Well, the trick is you kind of tilt the test tube like this, and then you open up your calcium carbonate, use a spatula, just to add it to the side of the test tube. Okay, so let me make it closer to you. So just add it here, but don't drop it. Try not to drop it. Just put it on the side like this. There we go. Okay, so this is how it looks like. We have the acid here, we have the calcium carbonate here. Now, we are going to take this test tube. Again, this test tube on my right, it contains lime water. And right now, I'm going to stopper the test tube with the calcium carbonate like this. Okay, make sure it's tightly sealed. So right now, you see this setup. So it consists of, on my left, the calcium carbonate and the acid not yet mixed together. On my right, we have the delivery tubing and the lime water. So right now, I'm going to drop the calcium carbonate into the acid, and let's see what happens. All right, now the bubbling has stopped. Okay, so first of all, this one on my right, this is the lime water. Now it turns milky. So what does it tell us? It tells us that carbon dioxide is produced from the reaction between calcium carbonate and hydrochloric acid, which turns the lime water milky. Okay, now on my left, so over here you see, perhaps I add too much of the calcium carbonate. You see more reaction occurs. And remember, this one we call it effervescence. Effervescence basically means bubbling. Okay, so I'm trying to react the remaining carbonate that has stuck on the inner wall. Okay, so I allow it to stand for a while, and this is how it looks like. So on this side, on my left, your right, this one is the hydrochloric acid and the calcium carbonate. So even though there are still some milkiness or cloudiness inside, but in general, you don't see any white precipitate. So that actually means that calcium carbonate dissolves in hydrochloric acid. To be more precise, hydrochloric acid reacts with calcium carbonate. Okay? Now on my right-hand side, on your left-hand side, even though the solution is pretty clear at the top, but you can obviously see a lot of white precipitate. So that one is actually the calcium carbonate, because if you remember, lime water, the reason why it turns milky when we bubble the carbon dioxide is that the carbon dioxide actually reacts with the lime water to form calcium carbonate. And calcium carbonate is insoluble in water, and that's why they exhibit as white precipitate. Okay? With sufficient time, the white precipitate sinks to the bottom, and this is how it looks like. Okay? So that would be the end of this experiment.